Alright, this is problem number 5 on section 3.7 optimization problems, and in this case we have two posts. Oops, let me get rid of that. Need a pen. There, we have two posts. A shorter one that is 12 feet high, and a larger one that's 28 feet high, and they're separated by 30 feet. And somewhere in between them is placed a stake, and I have a wire from each of those posts to that stake. And we're trying to figure out where to put that post in between these, where to put that stake in between these posts, so we use a minimum amount of wire. So I'm going to call this initially wire 1 and this wire 2. Okay, or W1, W2. And so I want to minimize the total. So here's my total right here. And at least gives me an idea that I'm minimizing a sum of two numbers. And so I want to get those two numbers in the same type of expression. Well, the hint is that they're 30 apart, and it's creating two right triangles. So this distance from the bottom of this post to the stake I'm going to call x, and from the stake to the bottom of the second post will be 30 minus x. That allows me to write both W1 and W2, each of those wires, in terms of x. For the first triangle, I'm going to have x squared plus 12 squared is equal to W1 squared, which means W1 is going to be the square root of x squared plus 144. So right up here I can start rewriting t, and I'll get rid of this W1 to begin with. The square root of x squared plus 144. Plus, now I'm going to do the same thing with this next triangle, and I know that I'm going to have 30 minus x, that quantity squared, plus 28 squared is going to give me W2 squared. Well, I can expand this, and I'm going to have 900 minus 60x plus x squared plus what is it? Plus 784 equals W2 squared. So that means the square root of x squared minus 60x, 900 plus 784 is 1684, is going to equal the length of my second wire. So over here I'm going to write the square root of x squared minus 60x plus 1684. Which means I'm going to get it in form so I can take the derivative of it. It's going to be x squared plus 144 raised to the 1/2 power plus parentheses x squared minus 60x plus 1684 raised to the 1/2 power. Alright, and so when I take the derivative, I got t prime over here. I'm going to have 1/2 x squared plus 144, then negative 1/2 times 2x plus 1/2 times x squared minus 60x plus 1684, then negative 1/2 power times 2x minus 60. Alright, which means I can simplify this to, well, the 1/2 and the 2 will simplify, so I'm left with x over the square root of x squared plus 144. And if I look at this, I'm going to have on my denominator the square root of x squared minus minus 60x plus 1684. And over here I could factor out a 2 and get x minus 30, and that 2 would simplify with 1/2. So I'm left with x minus 30 in the numerator. Alright, now I know I'm going to try to find the solutions to the numerator. Well, what I'm going to do is I'm going to make this equal to 0. I think that would be the easiest way to do that. And see if there's somewhere I can simplify that. And I really don't want to get a common denominator because it's going to become very, very complex. So what I'm going to do is use this 0 to help myself out. Plus 1684. And what I'm going to do is I'm going to subtract this amount from both sides, so I have a negative x over the square root of x squared plus 144 is equal to x minus 30 over the square root of x squared minus 60x plus 1684. And what I'm going to do is I'm going to square both sides. And I'm going to get x squared over x squared plus 144 is equal to x squared minus 60x plus 90. That's what I get when I multiply that out, over x squared minus 60x plus 1684. Now I'm going to multiply both sides, and I'm going to start writing it up here. So this is going to come all the way right here. So when I'm multiplying, I'm going to multiply diagonally. I can multiply these two products. I'm going to multiply these two products. So I'm going to have x squared times x squared minus 60x plus 1684 equals x squared plus 144 times x squared minus 60x plus 90. And when I multiply this side, I'm going to get x to the fourth minus 60x cubed let me rewrite that, cubed plus 1684x squared. And over here, if I multiply this out, I'm going to multiply first by the x squared terms, and then I'm going to multiply by 144, so I'll get x to the fourth minus 60x cubed plus 90x squared oh, excuse me, that's not supposed to be 90, that's supposed to be 900, because 30 times 30 is 900 there. That's why I paused for a second. So let me get rid of that. I'm supposed to have 900 here, 900x squared, there I go, plus 144x squared minus 8,640 x plus 129,600, excuse me. So I'm going to go and subtract, and this is going to be, those x to the fourth will cancel out. This when I add 60x cubed to both sides, that'll be gone. Over here I'll have 0. And when I subtract this, this is 1,044, and when I subtract that, I'll give a negative 640x squared minus 8,640x plus 129,000. I'm going to divide each of these by -10, and that's going to give me 0 is equal to 64x squared plus 20, not plus 27, plus 864x plus 12,900. And I'm going to divide everything by 32. So this will give me 2x squared plus 27x. This should be negative. Let me get my eraser. I'm making a lot of mistakes because I'm trying to go too fast. You guys are probably catching all this. When I divided by a -10, this should have been negative right here. And now when I divide by 32, that's going to be a -405. There I go. And so now I'm going to use the quadratic formula, and I have a -27 plus or minus the square root of 729 minus 4 times 2 times a -405 all over 4. And this is going to give me a -27 plus or minus the square root of, when I compute this, it'll be 3,969 over 4. And I think that gives me a -27 plus or minus the square root of 63 all over 4. And so I either get -27 plus 63 divided by 4. And that answer is $36. And 36 divided by 4 is 9. And if I do a -27 minus 63 over 4, I get -90 over 4, and I don't want that. I don't want it to be negative. So that means, if I go back to my picture, this is supposed to be 9. So I want this one to be 9 feet here, and this one to be 21 feet over here, because I'd have 30 minus 9 for the minimum amount of wire.